Soil and water conservation engineering. First topic in unit 2 was evaluation of USLE equation. Estimation of soil loss. Universal soil loss equation is used for estimating soil loss over a year. Here USLE, which means universal soil loss equation, which is given by Weismer and Smith in 1965. This equation is used in sheet and rill erosion, not for gully erosion. It is used for water erosion, not for wind erosion. It is compute average annual soil loss, not sediment yield. It is very simple and powerful tool for predicting the average annual soil loss. Whereas formula for USLE is equal to R into K into L into S into C into P. Whereas A is average annual soil loss, whereas R is rainfall, runoff erosivity factor, and K is soil erodibility factor. Next L slope length factor, S slope steepness factor, C cover management factor, C peak conservation practices. Where erosivity, it is defined as the potential ability of rainfall to cause erosion. It is rainfall factor. It depends upon the physical characteristics of rainfall, which includes raindrop size, drop size in distribution, kinetic energy, terminal velocity, etc. The erodibility is defined as the susceptibility of the soil to be eroded. It is a function of physical characteristics of the soil. It is a soil factor. The physical characteristics includes the texture, structure, organic matter content. A soil loss A, erodibility of the factor R, erodibility of soil, physical characteristics K, topography, management of soil, length of degree of crop cover conservation, slope, practices P. Where R greater than 1, it represents the erosive potential of rain, and it is related to the kinetic energy of falling rain and its intensity. The product of kinetic energy and 30 minutes maximum rainfall intensity is termed as rainfall factor as R or K into 30, whereas EI is erosivity index, KE kinetic energy of the rainfall event, whereas K30 is the rainfall intensity, I30 is the rainfall intensity for maximum 30 minutes duration, and N is the total number of rainfall event during a particular year. Whereas KE is equal to 210.3 plus 89 into log I, where I is the rainfall intensity, which is termed as a centimeter by a half. Whereas K is a factor which is related to the various soil properties by virtue of which a particular soil becomes susceptible to get eroded by water or wind. Physical characteristics of soil such as infiltration rate, permeability, soil texture, stability of soil structure, size, organic matter, and soil depth, generally influencing the rate at which the different soils are eroded. It is expressed as tons of soil loss per hectare per unit rainfall erosivity index from a field of 9% slope and length, a slope length 22.13 meters, which means 72.6 feet for a continuously clean fallow land with up and down slope forming. As the estimation of soil erodibility on the basis of runoff plots, which is the following equations, which is denotes a slope factor, total erosivity index, K defined as determining by the morphological of solutions, etc. For estimating soil erosivity on the basis of soil properties, K is equal to 2.8 into 10 minus 7 m into 1.14 12 minus A plus 4.3 into 10 minus 3 B minus 2 plus 3.3 into 10 minus 3 C minus 3. This is what the equation which is used for calculating soil erosivity factors. Wherein this m, which denotes particle size parameter, where m which denotes a percentage of silt and fine salt, and 100% of clay, where A which differentiate and denotes organic matter, B soil structure code, where one very fine granule is equal to 1 fine granule, which means 2 medium or coarse granule, 3 block or planetary massive, 4 C, which means profile permeability classes. For rapid 1, moderate to rapid 2, moderate 3, slow to moderate 4, slow 5, and very slow, which denotes by 6. Next, L, it is defined as a ratio of soil loss from a given length of the slope to the soil loss from the slope length of 22.13 m under identical condition, where the length of the plot slope length in meter, m is the dimensionless exponent. The table is given by Weismer Smith, which denotes slope m greater than or equal to 5%, which means 0.53%, which less than a slope less than 5%, 0.41%, and slope less than or equal to 3%, which means 0.3 plus greater than or equal to 1% of 0.2. whereas the parameter is, which is defined as the ratio of soil loss from a given slope gradient to the soil loss for the slope of 9% under identical condition. Whereas slope length greater than or equal to 4 meters, slope length greater than 9%, which means S is equal to 10.8 sine plus 0.03, slope greater than or equal to 9, which means S is equal to 16.8 sine minus 0.5. Next one is topographic factor, which means LS. Whereas the L slope length, S percentage of slope, per angle, slope angle variable depends on the steepness of the land slope. Next, C, it is defined as the ratio of soil loss from a field under known cropping system to the soil loss from a continuous clean fallow land under identical condition. This factor combines the effect of crop type, crop rotation, length of growing season, etc. The erosion effectiveness of crop and cropping practices is evaluated on the basis of 5 recommended crop stages. First one, period F, rough fallow land. Next one, seed bed farm. Next one, period establishment period. Next one, growing period. Residue and stubble period. Which in first one, which includes summer plowing, seed bed preparation. Next one, after preparing a seed bed, we have to transplant the seedling for a 1 month period. After transplanting, it has been established that up to 2 months. Next one, growing period, which refers to a period for crop harvesting, which includes last period, which means crop harvesting to summer plowing of new seed bed preparation. Next one, crop management factor is determined as the ratio of soil loss from cropped plot to the soil loss from the continuous fallow land for each of the above 5 crop stages separately. P, it is defined as the ratio of soil loss from a specific conservation factors, which is the soil loss from up and down slope forming under identical condition, was contouring factor, strip cropping factor. That is the main factor which involves in P factor. Next, what are the limitations of USLE, which means it is an empirical, it predicts average annual soil loss, it does not compute gully erosion, it does not compute sedimental. These are all the limitations while considering USLE equation. This is what we have studied in the basis of evaluation of USLE, USLE parameters, USLE farmland limitations. Thank you.